Okay, here we go. We're going to do a little lesson on symmetry, which is section 1.2.6 in your book. So in this lesson, our learning targets are to define reflection, rotation, and translation symmetry. And we're also going to identify, learn how to identify types of symmetry in figures. So what is reflection symmetry? Well, a shape is said to have reflection symmetry if it can be folded in half so that both halves match up perfectly. All right, and the fold line is called the line of symmetry for the shape, and shapes can have more than one line of symmetry. So here are some examples of reflection symmetry in basic shapes, and you can see each shape has some dotted lines drawn. Each of those lines is a line of symmetry for that shape. All right, so an equilateral triangle has 3 different lines of symmetry. A square would have 4 different lines for reflection symmetry. If you have a regular pentagon, remember regular means that all sides in the shape are the same length, and pentagon means it has 5 sides. A regular pentagon is going to have 5 different lines of symmetry, and a regular hexagon, meaning all sides are the same and there's 6 sides, that's going to have 6 lines of symmetry. Here are some examples from everyday life of symmetry. The McDonald's arches, reflection symmetry, right down the middle of the M. Butterfly, same deal, right down the middle. If we were to take the left wing and fold it onto the right wing, both halves would match up. Our Starbucks gal, she's got reflection symmetry, top to bottom, and so does the Canadian flag. So what about rotation symmetry? If reflection symmetry means we can fold an object in half, one half onto the other, and it matches up perfectly, what does it mean if something has rotation symmetry? A shape is said to have rotation symmetry if it can be rotated less than 360 degrees and match back up with itself again. The number of degrees that the object rotates through is important, and we use that to describe the object's rotation symmetry. So here are some examples. Okay, we have a regular hexagon at the top left, and you can see by those arrows every 60-degree turn to the right, or if we were to reverse it to the left counterclockwise, that hexagon would match up with itself again, okay? And so that means it has 60-degree rotational symmetry. Every 60 degrees matches up with itself again. The triangle is meant to be a scalene triangle, which means none of the sides have equal length. And so this is an example of a figure that doesn't have rotational symmetry because we would need to rotate it a full turn in order for it to match back up with itself again. And I have a quick little example here in Desmos for you. And you can see our little swirly pattern here. Okay, if I move this, so you can see here, this is telling me how many degrees I've rotated it through. So right now I've rotated it through 15 degrees. And I'll keep going until it matches up with itself again. Right there, a 120-degree turn makes this object match up with itself again. It has 120-degree rotational symmetry. So I would expect in another 120 degrees, or when I get to 240, I'll match up with itself again. And then when we go to 360, a full turn, we're back right where we started. All right, here are some more examples. The pattern on the left has 60-degree rotational symmetry. Okay, how did I figure that out? Well, I'm looking at the, I guess we'll call it like the star pattern that's kind of jutting out at the ends there. Okay, there are 6 of them all the way around. And so if I split that into that circle that it would rotate around into 6 equal sections, each section is 60 degrees. See, the star has 1, 2, 3, 4, 5 endpoints sticking out. So if I take 360 and divide it into 5 sections, every 72-degree turn is going to match that star back up with itself again. Here is some examples of symmetry in Cleveland, okay, both rotational and reflection symmetry. So this is a picture of the glass dome ceiling inside Heinen's downtown, all right. And so this has rotation and reflection symmetry. If you can envision that dome rotating left or right, okay, minus, the artwork and the pictures, but the general shape, the general architecture, it's going to match up. And if we count, let's count around here. Okay, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I think I'm counting 13 different sections here. And so if we take 360 degrees and divide it by 13, that means every approximately 27.7 degrees of rotation, either clockwise or counterclockwise, the Heinen's dome has rotational symmetry. Pretty cool. Here's another example. Okay, the stage at Severance Hall, home to the Cleveland Orchestra. If you can imagine a vertical line right, whoops, didn't mean to do that. Hang on, guys, let's go back. There we go. If you can imagine a vertical line right down the center here of that stage, okay, and again, little differences in the chairs, but in general, if you were to fold that over, the architecture has that reflection symmetry going on. All right, and my last example here in Cleveland, which you got a little preview of before, is the arcade, the first indoor shopping center in America. I didn't realize that it was the first indoor shopping center in America. I thought that was pretty cool that was right here in Cleveland. But, this view of the arcade has some reflection symmetry as well in the architecture. If you, were to draw a line right down the center here, that line of reflection there, okay, that would show reflection symmetry one half to the other. Okay, so the last type of symmetry we need to talk about is something called translation symmetry. Okay, translation symmetry is when a shape or a pattern can be translated onto itself. All right, so this often happens when we see repeating patterns, a lot of times in artwork and also in nature. So let's take a look at some examples. Here's an example from nature, honeycomb. All right, all of those, so each of the little honeycombs are hexagons, little six-sided hexagons. And, if you were to take one and slide it in different locations, it would slide onto other honeycombs. And that's what creates that pattern. All right, a brick wall, very simple example of translational symmetry. Take any one of those bricks, slide them around, and the pattern keeps repeating itself, and it will keep mapping onto itself. All right, and finally, here's just a piece of artwork I found, okay, that also showed translational symmetry. If you take a look at each of these different colored sections of the hexagon, you took that whole hexagon and just, slid it down on a diagonal or down and over a little bit, it would translate onto itself. All right, so that's an overview of symmetry. Okay, now that you've watched this video, continue on with the prompts in your HyperDoc and let me know if you have any questions.